right now. Those, I'm asking those who are in group 3 stroke 2B, what are you currently doing in class? This is when you guys are starting to be serious. Yes. What happened? For the 3B stroke 2B, 3B stroke 2B, what happened in okay, but I don't know. I thought everybody did CPA, and that's the reason why I came up with this. I had no idea that there's another book which is I know how this is class, but it's a must know. Like, it's one of those things where you have to know. Okay? So I thought of having this session so that I can try and help you out guys understand. These are just decisions. But every year, at each level, you will find this okay? So when you're going year 4 again, you keep advancing like that. I'm in year 7 and I'm still black as well. Alright, so I try to know that the ones that started CPS because some of the things you might not understand, but I was trying to help you to simplify everything. Okay? Alright, so what is ECG? Let's start with the definition. What is ECG? Can someone else ask the definition of what ECG is? And what happens to the skin? What happens to the skin? Those in group 1 and was it 1 stroke 2A? Help us with the definition of what ECG is. Yes, so let's be quiet. I don't have a mic, so for you to be able to get it. Okay, so what does it stand for? That's a good definition. What does it stand for? Anyone who knows what ECG stands for? Those one and let's be able to answer this question. My first question, what does ECG stand for? Divine electrocardiogram. What is the difference between ECG and EKG? Why are you saying ECG and EKG? Why did I write the EKG and ECG? So the American instead of so because we have the other people showing stuff, we call it ECG. American they replace the K with the C. Okay, but they're the same thing. Alright. What happened to this kid? There was a lot of diagrams okay. So for us to understand ECG, because he said, he said that when you talk about ECG, you're basically talking about the electrical activities of the heart. So before you dive into the activity, it's very important you we remind ourselves of the electrical activities of the heart. When you are doing muscle, I think we did talk about the cardiac muscles, right? They are divided into two. True or false? Yeah? True or false? Cardiac muscles are divided into two. True or false? What are the types? What are those types that make up cardiac muscles? Just raise up your hand like, this is just basic. Someone that I've done, like, the types of muscles, the types of cardiac muscles, that's all. Someone contracting and contracting. Good. And then there are three types of contracting myocardium. Can someone remind us the three types of contracting myocardium based on anatomy? And you're writing anatomy. Someone will help us with the three types of contracting. He helped us with the cardiac muscles can be studied. Those that are able to conduct this mountain and those that are able to contract. Okay? We hold on to the conducting one. Let's go to talk about the contracting one. So I want someone to list three types of contracting cardiac muscles. You are invited to anatomy. Let's concentrate on the conducting, because the conducting myocytes are the ones that are important when we talk about ECG. So the ones that are able to conduct impulses are the ones that have been highlighted, are the ones that are in yellow in the diagram on your screen. Okay? Those are what we call conducting myocytes. Okay? They are pacemaker cells, meaning they are able to generate an action potential spontaneously without any trigger. Like they just do it on their own. There's nothing triggering them to actually initiate an action potential. They just do it on their own. So we have different types of conducting myocytes. Okay? The ones that are found within the atrium, what do we call those that are found within the atrium? It's written, let's read it. We have the SA node, two parties from a thing cannot go. The SA node, and then you have the AV node. Between SA and AV node, there is a bundle that is connecting the two of them, which is the internodal pathways. Okay? So an action potential always starts from the sinus node spontaneously, and then it will be sent to the AV node. So that is, these two are our pacemaker cells. In a case where there is something wrong with the SA node, the AV node can pick it up and actually become the pacemaker cell. The pacemaker cell. Okay? So AV and SA node are pacemaker cells, but as long as SA node is active, it always fires first, way before the AV node fires. So SA node will fire first, before SA node will fire first, before AV node fires, you would have received an action potential from the SA node. So it is not given time, okay? But in a case where SA node is affected, the AV node always pick up and become the primary pacemaker cell. So once that action potential reaches the AV node, it now moves through the bundle branches. Okay, you can see these are the bundle branches. At this particular point, this action potential hasn't yet reached the contractile myocyte, the one we said. Okay, the aim is to that this action potential is targeting the myocytes. Okay, so once it enters the action potential enters the bundle branch, it now moves into the Purkinje cells. Do you know where the Purkinje cells are? Okay, too bad this screen has blocked much of the diagram, but the Purkinje cells are the ones that will now distribute that action potential to the myocyte of your ventricle. When the myocyte of your ventricle receives that action potential, what we should have in mind is what we learned when we were doing pathophysiology. That process of contraction is fiction. And when it happens, the heart will contract and keep the blood pump. It is making sense. Okay. So it is very important. So I said, SI node is the pacemaker actually continues to initiate action potential without any trigger, like without anything. But there are some nerves that can control the SI node, either to slow down or to, be sending those impulses that the function. So what are the nerves that come from somewhere targeting the hand? What is the name of those nerves that are targeting the SI node? And when they reach all the SI node, they will stimulate the SI node. By stimulating the action potential, the action potential is generated at the faster rate. What are those nerves? What is my question? Sympathetic nervous system. Where are then the opposite is parasympathetic. So it means wherever the SI node receives the parasympathetic innervation, it does the opposite of sympathetic. It slows down the SI node. Okay? By slowing it down, I think have to go back to the visual reduction and remember the E composite protein and the inhibition one. Okay, what is that? So now, what are doing is they have to wait. Where are those sympathetic and parasympathetic nerves coming from? Via the vagus nerve. Okay, that's very good. So you know that the only kind of nerve that affects all the cells outside the head and neck is the brain. So whenever they ask you what is the innervation of an organ, that they get it out from the brain. Because it's the only kind of nerve that comes out from the head and neck and is almost everything, excluding 2/3 of your what? No 2/3 of your what? Excluding no 2/3 of what? Excluding all these, I'm saying almost all the organs in the body are innervated by the vagus. But there is an exception of that. The organs of the pelvis are not innervated by the vagus. The organs of the pelvis are not innervated by the vagus. The parasympathetic innervation of the pelvic organs is not via the vagus. That's what I'm saying. What if it's not via the vagus? Then where are the parasympathetic nerves coming from? What is correct? The lumbosacral region. So right? And your answer of those questions are coming. Test one. Okay? The sacral region of your spinal cord has a lateral horn that produces autonomic nerves which are parasympathetic in nature. These are the nerves that will innervate your lower two-thirds of your GIT, meaning your large intestine all the way to your anus, including your vagina, including your penis, including your uterus. Because those are organs of your pelvis. Those are the questions you actually see in your test from the second. Okay? So the vagus is the one that innervates the heart via parasympathetic innervation. But you have to go deeper because where is it coming from? The left branch. Okay, I forget about the division of the vagus. If you want to trace the vagus, where it is coming from, where exactly it is coming from? Since it's targeting the heart, where exactly is it coming from? Because you know that the vagus that is going to the GI is coming from a different place. Okay, I'll give an example. The vagus that goes to the GIT to control peristalsis is coming from the swallowing center. Where is the swallowing center located? GIT, you guys think, right? So the vagus is coming from the cardiac center. Okay? The cardiac center is found within the brainstem, by which are the nerves. Okay? So the brainstem has a lot of centers. One of the centers you need to know is the respiratory center. You need to know it in and out. Okay, and how the breathing is controlled. The other one is swallowing or deglutition. You need to know the swallowing center in and out, the nerves that are going that side and those that are sent to the GIT. Now we are on CVS, we're talking about cardiac centers, okay? You have to understand how the heart is controlled, right? So the nerves that come from the cardiac centers to the heart are parasympathetic and sympathetic. If you are talking about parasympathetic, it is always through the vagus. So they are coming from the cardiac center. Now this cardiac center is divided into two, okay? There is a vasomotor center and the cardiac, I'll call it the cardiac center. Now this cardiac center is divided into two. The cardiac accelerator and cardiac decelerator. An accelerator is the one, that is where you have an origin of your sympathetic nerves. So whenever a cardiac accelerator is stimulated, those nerves that originate from the cardiac accelerator will come as sympathetic to what? To stimulate the SL. And then the heart rate will increase. The cardiac decelerator, on the other hand, that is where the parasympathetic nerves originate from, of course, to the vagus. So the vagus parasympathetic nerves that are targeting the heart are originating from the cardiac decelerator. So when there's a stimulation of that area, you will decrease the heart rate because it inhibits the SN of salary. Okay? The vasomotor center has nothing to do with the heart, but it targets all your blood vessels. Okay? So it is ever in stimulation, so it causes constriction of your blood vessels. When it is inhibited, those impulses won't descend and then there will be vasodilation of your blood vessels. Those are the things you need to know. I don't know what you are studying. That was a summary. When I was coming here, I had it in mind that everyone was on the same page, so just a walk over like that. Okay? Now you need to know. Now these are the very set. Remember here, I'm talking about the conducting myocytes. You need to know the action potential of these cells. Okay? Take note that the one that is in red is an action potential graph for the conducting cells, but the one that is in green is for the contractile miles, and you can see that different. Okay, even the ions that are used in contractile myocytes, they are different from those that are used in conducting myocytes. So you need to, those are the questions you will see in your either test 2 or exam. Okay. All right. So now we know that impulse starts from the SA node, it goes to the AV node, and it goes to the bundle branches all the way to the Purkinje fibers. You need to memorize the times. Yes. You need to memorize the time. How long does it take for the impulse to move from SA node to the AV node? You know, it's a math. Alright, so we can start with our ECG. Now that I've talked about that, because, yeah. So, like we said, ECG stands for electrocardiogram. Okay. So, this ECG, the normal ECG is composed of 3 waves. Okay. The normal ECG is composed of 3 waves. So, we have the P wave, the QRS, complex wave, and a T wave. Okay? These are the 3 waves you have. So the P wave represents the atrial. What? What does the P wave represent? Those in group 1 to group 8. So yes, that's right. Remember, we say that ECG is not about chemical waves. No, polarization is not that. No, polarization is that the ions of contraction has nothing to do with what you have been saying. It has to do with how sharp iron is about something and doing. Okay, so remember that these waves we'll be talking about under ECG, they have nothing to do with contraction of the heart. Instead, it's depolarization of different parts of the heart. Okay? So when SA node fires, the first myocytes to receive the impulse are obviously the atria, those of the atrium, right? Because the SA node is right there in the atrium. So it's actually, the SA node is located on the right side of your right atrium, right? And then when SA node fires, it distributes the electrical impulses from the right, and then they also go to the left before they even reach your ventricle. Okay? Because of that, the atrium are the first to be depolarized. So the P wave stands for depolarization of the atrium. Are we together? Yes. Okay. All right. This is good and it's not bad. Okay. So this is our typical ECG. So you can see you have the P wave there, R, Q, QRS, and then you have the T wave that side. Okay. So what does QRS represent? What does QRS represent? T, I expect you to understand. What does T represent? Repolarization. Okay. If you are saying T is the polarization of the ventricles, it means between QRS complex and T, what contraction? It happened and then they have to repolarize or they can repolarize. You cannot simulate the mass to repolarize and go back and then that's where the cycle machine. So between QRS T or the QRS and the T, in between the ventricles. So the P wave we are saying is depolarization of the atrium. So we expect to see a wave of repolarization of the atrium here. Why does an ECG have a repolarization wave of the atrium? Because P we are saying is depolarization of the atrium. QRS is depolarization of the ventricles. And then T we are saying it's repolarization of the ventricles. Where is repolarization of the atrium? That's the difference. Yeah, you are right. So she said, the P wave starts with depolarization. So the atrium receive, those atrial muscles receive the action potential. They got depolarized. They contracted. They need to repolarize, right? So now we should expect to see a wave for repolarization in this data. But we don't have, the next thing is we only see ventricles depolarize. And then they're telling us that the next thing is that the ventricles will end up repolarizing. But we don't have any wave for the actual repolarization. Why is it like that? There is someone who says yes? You need to speak up for us to be able to. The what? So I'm trying to get her now, since she doesn't want to speak up, yes? Okay, okay, I'll say no. Anyone else? Yes? Yes? You can speak loud. Shh. Guys, like we don't have a mic and other people want to be getting you, so it should be loud. So we have B representing depolarization of the atria, okay? when the atrium are depolarized, they contract. Okay, as they are trying to repolarize, the ventricles are also deep. But the muscles in the ventricles are way more than the muscles in the atrium. The ECG will just pick up the reading of what? The ventricles. So under the QRS, that is where I expect to see the repolarization of the ventricles, but you can never see it because of the pattern. Muscles in the ventricles are way more, so the machine picks up that of the ventricles. That is the explanation. Have you gotten the explanation? P-well is depolarization of the atrium. If you remember, let's use the cycle. Okay? Blood is received into the atrium. Okay? When the blood is received into the atrium, what makes the atrium has to go? You move from the atrium and then goes to the ventricles, right? And then when the ventricles are almost full, the atrium has to squeeze a bit of blood so as to form or to increase the pressure in the ventricles, right? True or false? Okay. Now, for it to squeeze that bit of blood, it needs to depolarize. True or false? Okay. So, the SA nodes fire. The atrium receives the impulses, it depolarizes. It will squeeze that blood, right, into the ventricles. At the same time, the atrium potentials already move to the ventricles, so they have to depolarize. So when the atrium is trying to repolarize, the ventricles are depolarizing. So, but the muscles in the ventricles are way more than the muscles in the atrium, true or false? So the machine, the machine will pick up the electrical activity in the ventricles instead of the atrium. It will be overshadowed. Is it clear? So if we were to remove the ventricles, you would actually see your repolarization wave of your atrium right where the QRS is. But it is overshadowed because of the thickness of the ventricles when they are depolarized. Because repolarization of the ventricles or depolarization of the ventricles happens at the same time when the atrium is repolarized. Clear? Okay. All right. Now, why is the T wave positive? If it is repolarization, it was expected to go down. Why is it up? Depolarization means positive charges are entering the cell, right? That is why the P wave is positive. It makes sense that our reference point is 0 there. Okay? So P wave makes sense. The QRS complex, it also makes sense that, okay, majority of it is positive going up like that because the cells are depolarizing. They are receiving positively charged ions. Okay? So, okay, it makes sense. But why do we have T as a positive instead of it going down? Because if it's repolarization, it means it will be losing what? Positively charged ion and should go down. True or false? But why is it up like that? Yes, no.
Since repolarization is just a process of cells losing potential, that is just basically the gain of negativity. And since repolarization starts from the ventricles down, going upwards, that movement is picked up by the machine itself as a positive wave. Since it's going negative charge going backwards, it's a positive.
Exactly. So the muscles of the heart, depolarization starts from the endocardium to the epicardium. Okay? Like the muscles, depolarization will start from the inside going outside. True. Anyone who doesn't know that? Okay, that's what happens. That's what happens. So when they receive that action potential, depolarization will start with those innermost muscles to the mid ones to those outermost ones. Okay. Now, when they're about to repolarize, you expect the inner ones to first what? Repolarize. But no, the ones that will repolarize first are those out from the outside. From the ones that are outside the middle. Because of that, the machine will pick it up as positive, like you said. Okay? Just take it like that. If you're not understood, just take it like that's how it is. Okay? Yeah. Okay, let's move on. Let's move on. So I want you to have at least you have at this particular point. All of us are on the same page concerning what is on the ECG. We know what P is. We know what QRS complex is. We know what T is, right? Okay. We also have to appreciate the intervals. Okay. So you have the RR interval. The RR interval represents what? The RR interval is between QRS complex with another QRS complex. What do you think that means? We're talking about intervals. What do you think the RR interval is representing? Exactly, you're right. So RR interval, it makes sense. In fact, if you pick T and T, it means that's one cycle. True, of course, it's true, right? If I pick R and R, it means there's a complete cycle, as in there's systole plus diastole that happens, so there's a complete cycle. If I pick any interval, P and P, R and R, T and T, these basically mean that there is a complete cycle, there is a complete cardiac cycle, okay? Then you have the QT interval. What does the QT interval represent? I already talked about it. QT interval, I did talk about it. Guys. Yeah? Okay, now this is very well. Okay. It's like I only have one student which is this guy. Okay, so the QT, I did talk about it. I said if you have depolarization, which represents QRS, then T represents depolarization. In between, obviously, there is what? Contraction of the ventricles. What about the PQ interval? PQ interval. PQ interval. Natural contraction. Okay? So now there are things you need to memorize. Yes, these facts, numbers and the like. I still can't remember it myself. But you need. Okay. Let me just skip this and let's go straight to this. Okay. For you to understand this is where I started. I don't know what happened with the screen, but yeah. Okay. Okay. So there is this meter here. Okay. So this is an experiment. Okay, they singled out a myocyte, and then they connected a lead on the myocyte. So this is a single myocyte, and then you connect a lead, and the lead always has a negative electrode and a positive electrode. Okay. So before stimulating the muscle, the outside of the muscle is always positive. True or false? Before a muscle is created, its environment outside. No, I'm not talking about the inside. The outside is always positive. True or false? True. Okay. Once you stimulate the muscle, it is the very same ions that are outside that will start going inside and leaving the outside all negative. Okay. So if you notice, this lead here, okay, one end was connected using a positive electrode, one other end was connected using a negative electrode, okay? So because the muscle is not stimulated and outside is positive, there won't be any electrical reading on the meter. To just show 0. Okay? Once the muscle is stimulated, the muscle will start depolarizing from this side going in this direction. Okay? So it means the ions from the outside, remember it was all positive, they will start entering the cell. Immediately they start entering the cell, the outside, the other side has become negative, and the reading, there will be a reading that will be seen on the lead. Okay, so you can see that it was drawn, the reading was drawn going up like that. Is it making sense?
No.
How is it not making sense? How is it not making sense? Yeah? I think it's straightforward, guys. Outside the muscle, you know, physiology is a build-up of everything. So if you understood the muscle, is it left physiology and how there is a lead that has been connected to a muscle. This is just this was an experiment. Okay, I want you to understand how those waves were formed. Okay, because that is how you get to understand the limb leads and these and that. Okay, so this lead, when it is connected to a muscle, they're just placing it on top, like or above the muscle. Remember, the muscle is surrounded with the electrolytes which are positive. Get the point, right? Without any stimulation, you don't expect to have any reading, because this can only, if you know your physics, you can only read when there are different charges on either end. Okay? So you have a negative electrode this side, a positive electrode this side. As long as the surface of this muscle is the same, it has the same charge, the lead won't read anything. Okay? But the moment the muscle is stimulated, you know that when the muscle is stimulated, there is depolarization. Okay? And it will start from where the stimulus is. Okay? In our example, obviously the stimulus started from X. Just look at the first diagram here. Okay? You can see from the first diagram that once the muscle was stimulated, on top they are showing to a negative number. And those negative, they are just telling you to say, ions now are inside. And now the cell is depolarized inside. Now, because outside is negative, and this electrode will start reading, because the charge that is on this end and the charge that is on the other end, they are different. So it will read and it will go like a thing going up like that. So it starts like pop, 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 until it reaches, until the charge equalizes. Like if the positive charge this side should be the same with the negative charge this side. The moment the negative charge starts surpassing the positive, the gamma graph will start going down. The moment you have negative throughout the muscle, you go back to your 0 where you started from. Is it making sense?
Yes.
That's how the gamma P wave was drawn, and that's basically how all those waves were drawn for your ECG. Okay, it's very, very important for you to understand this, especially when you start talking about the limb, you'll see. Okay? So ideally, you can see now the muscle on the, is it PC, the one that is partially cut? Diagram C. After the muscle completely depolarizes, they're all negatives on top. The next thing should be repolarization. So you can see the next diagram now, repolarization, your sodium ATPase pump starts sending those to my sodium out so as to bring back the resting membrane potential. So the outside is now becoming positive. So you can see there is a diagram, the other diagram that is being formed. It makes sense that repolarization here, your graph should go down like we said. Okay? So this gamma graph will be going down like that as more positive ions are being sent out. Okay? When there is equilibrium between the positive this side and the negative this side, that gamma graph going down will be halfway. It will be the maximum it can go. The moment the positive charge starts surpassing the negative charge, it starts going back to 0. So end up, there is another diagram which shows a complete negative wave going down like that. But I explained to say that you don't see this wave, such a wave ventricles because the depolarization starts the opposite. You've seen that you can only have that gamma wave going down if depolarization starts from this side, or repolarization, sorry. But the ventricles will start repolarizing from this other side. So the graph will still be on top. Okay? I'm really hoping people are getting it. Alright. I will skip this because there are more details to come. Yes, John?
Yes, sir. It's not like a really black.
Okay.
I can go back to this. Yes. The first place that's there, we are seeing like the bigger things, but the biggest connected. I know that I can tell you that you connect this meter. Right? Outside of the other side, the other side is
Oh, it was a trace. When a muscle is traced, you don't expect it to stay by the what? Short. The outer part was like positive. Yes, and then our reading here, the thermometer was at 0. So after connecting, you now stimulate the muscle. And then when you stimulate the muscle, what happens to the muscle? So you have to this is an experiment. You have to stimulate the muscle. When you stimulate the muscle, depolarization happens. So this part where the stimulation happens, there is an influx of sodium, right? Influx of sodium. So because sodium is coming from the outer part to the inside is the one that is becoming positive. Then the outside is becoming negative. And now, because of that, you have different readings. Then that kind of thing will reach the value, and this is the value that was supposed to be going like that. All right, let's move on to this. I don't know what happened. Now, this is why I was expecting you to understand. But what happened to this screen? Okay. All right. So now, the reason why I spent time explaining this, because I want you to explain now this. We'll be building up slowly but sure. Okay? Okay. Now you know that the SA node is located within the atria, somewhere. That is where the SA node is. So because of that, the muscles that are closer to the SA node, they are the first to depolarize. True or false? Okay. So if you get this link like that, you connect it at the base of your heart, somewhere here, and you connect it at the apex. So remember, depolarization is moving like that. So it means those muscles that are found at the apex will be the last to depolarize. So when you connect your lead like that, it will show whenever the muscles on the base depolarizes, because they're the first to receive those action potentials, the outside will be negative and the inside will be positive, and the negative outside on A plus the positive on the apex, because the apex is the last to depolarize, will actually show you a reading. That is how those leads work. I'll talk about them. Is it making sense? No. How is it making sense? How is it just making sense, guys? What is who says no? What is confusing there? What has confused you so that you know how to help you? Who said no? Yes. No. Action potential starting from the AC. They find those muscles on that area receive that action. They depolarize. By depolarizing here, the confusion probably is that depolarization you're thinking inside the cell. To forget about inside, think about outside. Don't think about what happens inside. Inside we know that there will be positive ions going inside. But we're interested on the outside. Remember those positive ions, charged ions, They are the ones that will eventually go inside. When they can only do that when the voltage-gated sodium ions have been open. So ions outside, which are positive, will enter inside. And if you look at this diagram, maybe you cannot see, I also can't see, maybe if I move inside. There are negative charges where the arrows are starting from, outside the heart. It's telling you to say, well, after depolarization has happened, the ions have entered inside, and now the outside of the heart is negative. But towards the apex, the impulses are yet to reach that side. Remember, we start from SA node, AV node, bundles of his, then Purkinje like that. So, but the action potential is yet to reach your apex. So your apex is still positive, and when it's like that, you have a reading. And when the entire heart is in a depolarized state, the reading will go back to 0. Meaning it will go like that, reach the climax, then go back to 0 when the entire heart has depolarized. Meaning when the entire heart has lost from a negative all the way up to the apex. Does it make sense? Yes, Joe. I can't get it. They are what? They have? Yes. They are the first one, the muscle. No. Here we're talking about how the waves are moving like that, okay? But when we're talking about depolarization of the ventricles alone, we said depolarization starts from the outside going inside like that. There are two different things. Here we're talking about depolarization from the base all the way to the apex, okay? But when you reach the apex, okay, when you reach the apex, remember the apex, that is where the ventricles are. When the wave is going like that, the muscles that starts depolarizing first are those that are inside going outside. But when you reach the apex, the muscles that will repolarize first are those from the outside going inside, which is different from those that are found in the atrium. Atrium will follow the same sequence, okay? Those that depolarize first will repolarize first, but the ventricles they will do it all. It's now clear. Yes. I don't know if it has made sense. Okay, you can go and read your answers, but I've tried to. Right.
Looking at the muscles that go on one ECG, okay? Whatever happens to one part has to flow through to the last part. So we are saying, when the action which comes, okay, it is beginning from the inside, okay? The endomycin, ending at the epimycin, okay? When we reach the apex, the opposite is true. So now here it is. When an action which comes, okay, what happens? Depolarization, isn't it? That is why when depolarization is happening, that is why you see that canal, that machine going up, giving us a wave that is rising up, right? Okay, so now, when we reach that depolarization I'm talking about is the atrium, okay? So the atrium has depolarized, reach up. What do we expect? We expect the atrium now to repolarize, right? But because their muscles are fewer than those ventricles, we pick it up from the ventricles because there will be more, and it begins coming down. And that is why instead of seeing something coming down, we'll pick up the ventricles, depolarizing. That is why we saw something going up. Do you remember, right? Yes. So now here it is moving as a wave. From the atrium, we are now where? In the ventricles. So from the ventricles, we go outside. We are now at the apex, okay? Which we expect to now start depolarizing because it was depolarizing. So now, where is the confusion coming? Instead of us going from the beginning, we are coming now in the reverse. So in the ventricles, it will be a reverse form. Why? Okay? So in the atrium, it's not the reverse that is going to happen. They will follow the normal flow. Thank you.
Right, is it clear now? Okay, let's move on. If it's not clear, you can go to your Gano. Okay? Alright, now this is how, so your ECG does not look like this. This diagram looks very beautiful than ECG. So this is an ideal ECG, that's how it looks like, okay? So you can see, this was a question for 60 days, okay? But I am interested in just okay, so you can see that's how it looks like, and you are able to, at this particular point, you are able to label them and align, okay? Let's move on to, and add on what we started talking about, the leads, okay? So we have what we call as the bipolar limb leads. Okay? So if you just understood this explanation here, or this other explanation here, then these leads will be very easy for you to understand. Okay? Very, very easy for you to understand. Okay? So you can see that the bipolar limb leads, there are three of them. Okay, there is limb lead 1, 2, and 3. I want someone to point out the differences between limb 1, 2, and 3 before we go into the details. Just by looking at it, that. So these leads have been connected. I'll explain how they are connected and the like. But I just want someone to explain to point out the differences.
Because the short care is waves linked to
Okay. Okay. So someone to help us out. It's a straightforward question. Guys, it's a straightforward thing. Have you seen the lead 1 here?
yes,
Have you seen the waves in lead 2?
yes,
They are bigger or taller than those in lead 1, right?
yes,
And then the one for lead 3, they are taller than those in lead 1 as well, but shorter than those in lead 2. Okay, so the explanation lies in this explanation where you are going to connect your limb leads. Okay, if you look at your limb lead 1, your limb lead 1, which is this one on top. Why is it not top? Your limb lead 1, which is the one on top there, it has been connected to your right. See? Your right what? The right hand of this person on the screen and the left hand of this person on the screen. Now, the right hand, in comparison to the left hand, it means the right hand is where depolarization of the heart happens first, because it's closer to the base. It all goes back to this. Your right hand, which is this side, is closer to the base where depolarization happens first. So if you put a lead on your right hand like that, it means it will be, the reading will come out like that. So that's how the one reading will come up, or will show up like that. Because it will be moving from, it's like electrical impulses are moving from the right side to the left side, because the left side, that is where your apex is, the outermost part of your heart, which is the last to depolarize. Is it making sense?
yes.
It's a straightforward thing, just need Okay, let me move on to the second limb. Is it second limb? Okay, which is this one here. Okay, if I expand here, you guys will see. So you can see this other limb lead has been connected to the right hand. Again, the reason why it is being connected to the right hand, for you to have the drawings, you always need to connect the limb lead from the base where the negatives will start from first. True or false? So your right hand is still closer to your base, okay? And then the other, the positive, the negative will be connected to the negative, which is the base. The positive electrode is going to your right leg, left leg. Okay, because your left leg ideally is the one that is closer to your apex of the what? So the electrode that is positive will go to the positive left side, which is closer to the apex. The negative electrode will go to the right hand, which is closer to the base of the heart, which is always first to depot, which is always the first to become negative. Is it clear?
Yes.
Okay. And then you have this reading here. Okay. And then lastly you have the limb 3. Okay. Limb 3, you have the negative electrode being connected to. Now here's the thing with limb 3. Both of the electrodes are being connected on the right. Now on the right, we are saying that the entire thing on the right is expected to be positive because that is where the apex is and it is always the last to be depolarized. But between the two, between the hand and the leg, which one is more positive and which one is more negative? Which one is closer to the heart? Which one is far away from the heart? Yeah? The hand is closer to the
Heart.
So the negative electrode of limb 3 will be connected where?
To the hand.
The negative electrode of limb, remember on limb 3, and you have to connect this electrode and it's good and it's hidden there so you can't see. So the negative electrode, where is it going to go? The left hand or the left leg? Why the left hand? You remember talking about negative electrode. Why? Remember, these electrodes we're trying to connect them where the chances of you finding negative charges are and chances of you finding where the positive charges are. They are on the left side, and if you agree to that, in comparison to the left side of the body, if you are talking about the heart, because the heart's apex is more on the left. So whatever you connect here should always be positive, and that is why the 1 and the 2, all the positives are going to either this or this, true or false. Then the negatives are going to this other side. Okay? Now we are in limb 3, but limb 3, all the electrons are being connected to the same side. So between the two, which one is more positive and which one, in short, which one is more closer to the apex and which one is more closer to the base of the heart? The leg is more closer to the base, so the negative electrode of limb 3 should go to the left leg. The right hand, this right hand, you can say this is far away from the apex, guys. Obviously, the left hand is closer to the apex, meaning the negative of the positive electrode of limb 3 will go to the left hand, while the negative electrode will go to the left leg, because it is assumed that the left leg is the one that is closer to the base, while the hand is closer to the apex. Has it made sense? So this is now this is the last time, so if you get it, you don't get it. Okay, let me go through them again, okay? We are talking about 3 bipolar limbs.
What's the time?
What you need to know about these limbs is that they are only connected to the limb. That's the reason why they're called limbs. So you're connecting them to the limbs, either the upper extremities or the lower extremities. But we explained here that for you to have a reading in a limb, the other electrode, which is negative, should always be connected to the area of the heart that will depolarize first, because outside will be negative. And then the other electrode that will be positive should be connected to the area of the heart that will be least likely, that will be the last to depolarize, which is usually closer to the apex. For you, when you connect them like that, that is when you have a reading. Like you can see from the diagram, there's a gamma reading somewhere here after it was connected like that. Now, for the limb leads, you are only connecting these limb leads to your extremities. Okay? Limb lead number 1, you are connecting your negative electrode to your right side. Why? Because the base of the heart is the one that is closer to this. So if you connect that limb to your right side, which is negative, it's closer to the base, it's like connecting it like this, going like that. Because this right hand, this side, is closer to the base, so meaning it will, the electrical impulse is able to be detected like that, to say that the heart has depolarized like that. While the positive, which is the B in limb lead number 1, it has to go to the apex, but since we are restricted to the limbs, which limb is mostly closer to the apex? Obviously, it is the left. So when you put them like that, you have a reading, and that is what is going to show. You still have your P wave, your QRS, and your T wave, but they're just smaller, or they're like smaller in size, okay? Then the second limb, which is limb number 2, okay? Remember, we are restricted to connect these limbs to our extremities, okay? So, limb lead number 2, you have a negative electrode and a positive electrode, okay? The negative electrode, which limb is closer to the negative side of the heart, which is the base?
The right hand.
Yeah?
The right hand.
It is the right hand. So you can say that the negative electrode went all the way to the right hand, because the right hand is still the one that is closer to the base. Look at the diagram the way it is. The heart, the base of the heart, the one that depolarized first, meaning the outside will be negative, is always closer to the right hand. Okay? That is why in number 2, the negative electrode has been connected to the right hand. Now, you cannot go and connect to the other side, because if you connect to the other limb, which is your left upper extremity, it will be, it's like you are recording limb lead number 1. You have to record a different read, okay? So apart from where limb lead number 1 was connected, what is the closest limb that is closer to the apex, which is positive?
The left leg.
It is the right leg, not the left leg. Oh, sorry, the left leg. It is the left leg. It is the left leg that is very closer to
The other.
yes. Okay. So the positive electrode of limb lead number 2 was then connected to the left leg, which is closer to your base of your heart, because it is the last part to depolarize. Okay? Lastly, now we move on to limb okay? So you have an electrode that is negative and an electrode that is positive. You are only now restricted to connect this electrode on your left side, which is either your upper extremity or your lower extremity. Which of these two is closer to the base of your heart?
The leg.
It is the left leg that is closer to your base of your heart. So the negative electrode of limb number 3 goes to your left leg, while the positive electrode will go to your right, left hand. Okay. Now, between these three, you can see that let's define that. Limb number 3. The electrical activity is in lead number 3 are more as compared to 1 and 2. So overall, when you connect it like that, it tells you that the connection between the lead number 2 is the one that is closest to the heart, and that is the reason why it's able to pick up higher amplitude of electrical activities. So lead number 2 is, after connecting like that, you can say electrical activities in 2, they are higher in terms of my graph. The graph is still the same. There is a P wave, there is a QRS, and a T. But the amplitude tells you to say that the limb number 2 is the one that is the closest to the heart as compared to these other limbs that you've connected. Meaning, as you keep going away from your body, there's a point where you cannot even record anything. Is it making sense?
Yes.
So, that is it. Now, I want you to understand this. It comes in your MCQ. Interven's triangle. Okay? It's something that pops up. So, I expected the group 1 that is not right. So, in China, but you guys group 1. Okay, so interven's triangle is just simple. Interven's triangle, I'm just telling you to say that if you know the values for any of the limbs here, if you know the values of any of the limbs here, you can easily calculate and find the value for the other limb. Okay, so interven's triangle is lead 1 potential plus lead 3 potential will give you the lead 2 potential. If you know the reading of lead 1 plus the reading of lead 3, you can calculate by adding them up to find the reading of lead 2. So in short, you don't even need to connect it. You don't even need to connect all 3. You can just connect 2 and find the reading of the other. Is it making sense?
Yes.
There is a triangle there, so it's called the interven's triangle. And this triangle is just telling you to say that if you have known values for the 2 limbs of the total 3, you can easily find the base. Okay? So the formula is just, there is a blank screen there. The formula is lead 1 potential, meaning the reading you get in 1, whatever volts you get, plus the reading in 3 will equal to, will give you the reading in 2. So in short, if you know the values of 2 and you know the values of 1, you can make lead 1, lead 3 subject of the formula by taking it to the other side and still find lead 3. So just know the formula. Lead 1 potential plus lead 3 potential is equal to lead 2 potential, and that is what is known as interven's triangle. And if they ask you to define, just write the formula and you get your 2 marks. You don't need to stress it away. Okay? We move on to the other types of leads, which are the sensitive leads. Okay? So remember, I want you, at least if you have Wasokonism, a take-home message that the leads we are talking about were connected to the limbs. These other ones, they have nothing to do with the limbs, but we are now interested in the precordial area. What is the precordial area? That area we are most likely to find your heart. That is the precordium. So the precordium is that part of the chest. You are most likely to find your heart. There are some people where their precordium is on the right side. There is trochanter, okay, where they were born with all the organs. The trochanter is when the heart is on the left or when the heart is on the right. Situs inversus is when all the organs are opposite. But you guys that are not remember that. Those are the things you need to know for a girl. Anyway, let's move on. So we are now talking about chest leads. Okay? Let's keep quiet and move on. So chest leads. Okay? So these ones, remember, the principle is still the same. Okay? The principle is still the same. The only difference is that you have these leads are about 6 of them. There are 6. V1, V2, V3, all the way to 6. So the way they are connected in such a way that V1 should always be closer to the base of the heart, and V2 should be slightly going towards the apex, and the V6 should be the one that is closest to the apex. That's how they are connected, and they are connected at the precordial, right? Okay? Have you understood how these are connected? I'm going to talk about the readings. So connection, the first limb is connected at the base. Okay? The base of the heart. Meaning if you go back to this diagram of mine, the limb 1, is it not limb 1? Limb 1, V1 will be somewhere towards the base. And then the limb 2 will be going like that towards your, this is our right side, right? That's how they are connected. But here, they have nothing to do with the, they have nothing to do with your extremities. Now, have you noticed something here about the waves? I want you to appreciate the waves. That is where the limb that is closest to the base. Look at what when they go this way. The QRX complex is what? Is down instead of up. It makes sense. True or false? It makes sense why it is down, because that limb, that V1 was actually connected where the heart is the most negative, because it always starts from there. And then if you look at your V6, it is positive. Okay? So if you go from V1 to V2, as you are going towards your apex, where you expect the heart to be the most positive as the depolarization is happening, you can see that the wave is changing, and when you reach somewhere 4, actually 3, it becomes isoelectric. The gamma QRX complex becomes isoelectric. So I just want you to memorize, let's memorize it as such. It says V1 gamma took apart. Like just remind that. So when are given, whenever you're given an ECG, you look at this V1, V2, V up to 6. You notice that the V1 and V2, those machines are up. Then there is an abnormality. There is a problem, and that is why our CPS comes to, because you need to know this. Okay? So I want you to memorize it as such, and it makes sense as you are going towards the apex, the QRX complex is becoming more positive because of the explanation here. Okay? But again, it's like at V4, it is the maximum. The highest amplitude is at V4. After V4, it's like you're going away from the apex, so the charge is now decreasing. So V6, you can see it's positive, but it's telling you to say it has been placed a bit far away from the apex. No, think about it. Okay. So that's what I want you guys to get. And one thing I need to mention, because these leads are placed on your precondition, the relevance of these leads is that they will always tell you the structural abnormality of the heart. If, remember, V1 and V2 has been connected closer to the base, and the base is where your atrium is. If there is hypertrophy of your right atrium, the V1 and V2 will be positive. If there is hypertrophy of your right atrium, if you take note of that diagram, V1 and V2 have been placed somewhere where the right atrium is. Let's assume there is hypertrophy, there is a pathology that has caused hypertrophy of your right atrium. It means V1 and V2 will be actually positive. You now have more muscles at the base, and because you have now more muscles at the base, the depolarization will change. What you was expecting, everything will just change, and the V1, V2 will become positive. So my point here, take home message is, record your leads, they tell you structural abnormality. What type of structural abnormality? Whether there is a hypertrophy of the ventricles or the atrium, depending where, yeah, like this, for example, V4 and V5 and V6 can tell you if there is a hypertrophy of the left ventricle, because there will be more positives than they are right now. So that's a take-home message. At least get that. Okay? So those are the chase. Okay? There's a question. Oh, yes. So when they actual, they no more balance. They will let you know what nothing will be. But if there's a part of either on either part of the hand, to change to stabilize. Okay? We move on. So I know by the time I'm done, we have like 3 students, and those are the ones that came. So let's move on to. So you can see now this beautiful diagram shows you. This is a cross section of the human being somewhere where the heart is, and they're telling you why is there national black thing? Okay, showing how the leads have been connected towards the epipodia. So if there's a hypertrophy of the heart this side, lead number 1 and lead number 2 will be affected. Instead of them being negative, being down, they will be up because there are more muscles and there's more depolarization in that side. Okay, and then everything else will be affected. So this is what I want you to appreciate at least for now. Let's talk about the last limb list before we talk about the 12 ECG. Yes? Oh, the right, it's considered to be a neutral leg. They're like, it's neutral, even when you're connecting the ECG and okay, they go, so when you're connecting your ECG, the neutral lead is the one that goes to your right. It does not detect any exposure. The neutral lead is actually black. You'll see those in 5. The 4. Okay? So augmented limb lead, so augmented unipolar limb lead. So what I want you to appreciate where these are concerned, at least you now have an idea of bipolar limb leads. They are all positive, but the bipolar limb lead 2 is the one that has higher amplitude as compared to 1. At least you memorize it like that. Then for the precordial limbs, the first and the second, the QRS is down, but as you keep going in this direction, they are becoming positive until you reach at 4 where it becomes isoelectric. But when you keep going in this direction, the amplitude will decrease. Now you have these unipolar limb leads. So unipolar limb leads, there is AVR, AVL, and AVF. Okay? So AVR just means it's connected to your right hand. AVL is connected to your left leg. They are unipolar, not bipolar. And then AVF is connected to your foot. Okay? So these are the limbs you need to memorize. So this one, just memorize the massage. Just note that LDR is the only wave that has the QRS going down. I don't want you to understand how it happens. Just memorize it like that. Okay? Memorize it to say that LDR, always when you're reading your ECG, you're giving your ECG. The first thing you should do is check your limb leads. Are they normal? By normal meaning is the limb lead 2, does it have higher amplitude as compared to these other? Okay, good. You check. You got your precaution leads. Leads. Sorry. Is B1 and B2 down? Okay, good. You go now to your augmented limb leads. You should always be checking your FDR. If it is negative like that, there is good. FDL and FDF is always be positive. Okay? With that said, that is where now the full ECG will come from. So at UTH or anywhere in the world, there is no such a thing as your ECG is just a single thing. It will have all the leads because each lead gives out different information. Are we clear? So an ECG has all the leads, the 3 bipolar limb leads, the 6 precordial leads, plus the augmented unipolar leads. That's what makes up the 12 ECG leads. Okay? So all of them are now what is considered as the 12 ECG. Okay? Now this is now where the questions come. I have some 3 or 4 questions, exam questions you will see. Okay? So ECG paper. So ECG paper, when it is recorded, when you connect those things, you are connecting everything and reading will give you all the 12 things. Okay? So you need to understand to say that you now need to understand the boxes and the line. This is where now we're heading into the boxes, and this is understood. Okay? So if you are talking about an ECG, a typical ECG, okay? Each large box is 5 millimeter wide and always represents 0.2 centimeters. Okay? And then those smaller boxes, so you can say, this I can't point. That's the fact. There is a big box, and in that big box you have smaller boxes, which are about 5 of them. So those small boxes in each big box, they represent 0.04 seconds. I'll repeat. The big box represents 0.2 seconds. Okay? Then there's smaller boxes in the big box, because there should be about 5 of them. They represent 0.04 seconds. Okay? Alright, so we now know that a 12-lead ECG should always have a T wave, meaning when I'm talking about those limb leads, if you check them, you should be able to see a P wave, you should be able to see a QRS wave and a T wave. Same goes with the precordial leads. You should be able to see your P, QRS. Okay? So the baseline is an imaginary line. So there's an imaginary line where those, where these waves are starting from. So it's a reference point. That's our 0 line to say. So any wave that goes up is positive. Any wave that is going down is negative. Okay? All right, so we know how to measure waves. So we know how to measure waves. So this is how you measure waves. So your baseline is like that. So if you want to measure a wave, just measure how many millimeters is it going up like that. For example, the one that I gave in the first diagram, I'm showing that the amplitude is about 12 millimeters. So that's how you measure. So you have to, for you to know that the amplitude of lead 2 is different from 1 and 3. You have to measure, you have to have an idea of the normal, so that when you measure, if you don't find the normal, you'll be like, no, there's something wrong. Okay? So height is up, depth is down. Okay? Okay. So now whenever I'm given an ECG, because it is coming in your exam, whenever I'm given an ECG, okay, when they tell you to interpret the ECG, you just don't go to the abnormality, even if you've seen it. You start with the name of the patient. There's always a name of the patient somewhere at the corner. There's always the date when it was taken. So this is an ECG of Nyambe, taken at this particular date at the University Teaching Hospital. Okay? That's how you start. You just don't go straight to the abnormality. I can see the inverted field. You get a 0. Okay? Are we together? Okay. So now, after reading the initials, the ones I've talked about, you now have to standardize. You have to check if the ECG is worth reading. Okay? So you have to check the 10 little boxes in height at the corner. Okay? At the corner there's a camera, I don't know if they call it a triangle or a rectangle, the camera thing that goes like that. You should be able to count the boxes. There should always be 10 of them. If there are 10 of them, that means this is a good ECG and you can go ahead with your reading. So the first thing after checking the details of the patient, you should go at the corner, count the number of boxes. There should be 10 little boxes in height. And I'm talking about the corner where there are those okay? So count them in height, meaning they should always be 10. Alright. You know the reason later on. Just know it like that. Because you want to pass. Okay, I'm now perusing because the trickiest part about this is because I'm explaining those very same things I was explaining, but the rest are just straightforward. Okay? So methodology, measurements and the clinical significance. If you believe in that you write the PQRS, then you are doomed. Okay? You need to know the clinical evidence. Okay? So you are given an ECG. You read the details of the patient, you check those 10 little boxes that are there. The next thing is now, before you even go to your abnormality, if you've seen it, you've seen it. Measure your heart rate. You have to measure your heart rate first. That is the first thing you do when you're reading it. Okay? So, the heart rate is defined as the number of times the heart beats a minute. Okay? It is a significant thing in medicine. Okay? You need to make sure that when you're given an ECG, in an example, I have examples of questions I'll show you. People are getting serious because they just go straight to the pathology. And then the marks are, whatever steps I'm talking about, to be like, give 1 mark for this. If a student says this, give 2 marks. That's how we get marks. Okay? So you have to now measure your heart rate. How do you measure your heart rate using an ECG? Okay? One thing I need to mention is that, remember the ECG I'm talking about is a 12 ECG units. So you can use any of those to calculate your heart rate. Okay, but the preferred is usually in 2. Okay, the 2 is the preferred, but you can use any. Alright. So, yes. Ignoring the heart rate on ECG is the single most common mistake we all medical students make. Okay, they don't get marks and find that as 4. Alright. So how do you measure the heart rate? Okay? Very simple. I don't know what you are taught in class. This is the simplest. The number of boxes. So by the way, the interval you are interested in, remember we said that when you pick a particular interval like RR or PP, it tells you a complete cycle. So that is what you are interested in. But always be using RR interval when measuring your heart rate. then divide the number of boxes between the RR interval into 1,500. As simple as that. The number of boxes between this RR interval and by the way, when I say boxes, I mean those smaller boxes where we say they represent 0.04 stable. Are we together? So divide 1,500. Whatever number of boxes you find, just get that value and divide it into 1,500. Then it will give you your heart rate. A good example is this. From that end to that end, there are 26 boxes. So 26 you divide by 1,500 divided by 26. You have 58. So that is your heart rate. 58 beats the minute. 58 beats the minute. Okay? Is it clear? But the thing is, when I go, I'm not coming back. So you just have to finish. I might not come back, not because I don't want to. The course and I in school. So yeah, we are in our final rotation and it's just that. Okay? So yeah, that's how you can get the value. Now this value that has been found, which is 66, is within the normal range. What is the normal range? Normal range of heart rate. The normal heart rate range. What is the normal heart rate range? It's a range. It's not a single number, it's a range. I want to take from this to this. Yes, no. 60 beats to 100, that's correct. So that is the range. The normal heart rate should be between 60 to 100. The value calculated on this example is 8, which falls within the normal. So the size, which is not within the normal, but it's below 60. Okay. So the sinus here is called bradycardia. Okay, meaning bradycardia is when the heart is pumping at a slower rate. So bradycardia. So this is bradycardia. If you had found an answer that was between 60 and 100, we would have said this is sinus rhythm. But this is sinus bradycardia because the value is below the normal rate. Okay? Sinus tachycardia is when your heart rate is above 100. Anything above 100, sinus tachycardia. Anything below 60, sinus bradycardia. Anything within, it's sinus rhythm. Are we together, right?
Yes.
Okay. So at this particular point, you calculated your heart rate. Depending with whatever you find, if it is below, you have to conclude to say the value I found is below the range, the normal range, hence this is sinus bradycardia. Or the value I found is above the normal range, hence this is the sinus tachycardia, or maybe sinus rhythm. Okay? This is another example here. This other one you can see after calculating the number of smaller boxes from RR interval all the way to the other RR interval, there are 23. Dividing it into 1,500, you find your 65. Your Dr. Rindu will give you a different formula which is complicated. I don't know. For those that are in group 1, is it group 1? What formula were you given? It's the same one? Oh, excellent. Right. Now take note that this formula, the 1,500, is only used, I need to mention, only use this when the heartbeat is regular. Meaning the RR interval should always be the same. If you find that the RR interval of this other wave is different from this other one, you don't use this. This is for the regular heartbeats. Meaning the RR interval should always be there. The same. Because when you can number of boxes, either any of those, you still find your 23 boxes. Where is it? Where is what? I said that's not right. You want to know where it's coming from? So that's memorized to say that the number of boxes it compares as long as it's regular, I just need to divide it with 1,000. That's all. No one will ever ask where okay. All right, so this is the yes.
Excuse me. Excuse me.
Fibrillation is irregular heartbeats. When the heartbeats are regular, then that is irregular. They are getting it. They are called arrhythmias. The difference between arrhythmias and the sinus rhythms is that in sinus rhythm, there is regularity between intervals. The distance between this R and this R is always going to be the same. The moment you see these are two boxes, these are 27, these are two, that's called an arrhythmia. And there are different types of arrhythmias. You have atrial fibrillation, you have ventricular fibrillation, those are things you have to do. But what we're talking about here is nothing to do with arrhythmias, there are anything next to talk about. We are not going to talk about it. But you need to start. Okay? Now, this is a question, famous question most of the people fail come. Okay? They will question that usually comes, they want you to estimate the upper limit of sinus tachycardia. Sinus tachycardia is above 100, but what is the upper limit? The highest one can go before they collapse. Because if they exceed the upper limit, it's like the heart and the brain won't receive oxygen or nutrients, and then the patient will die. Okay, so you can calculate the upper limit of even yours. You can calculate it today by using this formula: 220 minus patient's age in years. So just put your age there, subtract. That will be your upper limit. The highest your heart can go in terms of heart rate. Above that, then you are gone. Yeah? All right. So when the heart rate varies by more than 10%, the rhythm is called sinus arrhythmia. And an example is the situation we are talking about. Okay? Sinus node, the master and servant. I think I will explain this. I started with this. So this is where now the parasympathetic and what, but I'm skipping this because I explained this. You know what's going to happen when sympathetic nerves stimulate the sinus node, there will be tachycardia will be the results, right? Then bradycardia is because of who? Parasympathetic. Parasympathetic. So sinus tachycardia represents a relative imbalance in the normal sympathetic parasympathetic balance of the heart. So there are two basic causes of sinus tachycardia. So it could be increased sympathetic activity or decreased parasympathetic activity. Too much sympathetic stimulation, you can end up having sinus tachycardia. Decreased parasympathetic, there should be a balance between the two. So if the parasympathetic are not stimulating the heart as compared to how the sympathetics are stimulating the heart, then someone might end up having sinus tachycardia. Okay? So you also need to know possible causes of what can cause stimulation of the sympathetic so that someone ends up having tachycardia. bleeding is a good example. Someone is on menses and they are heavily bleeding. They will be losing a lot of blood. What happens? The volume will decrease. It will be sensed by what? The baroreceptors. True or false?
True.
The baroreceptors, remember the example I'm giving is someone probably they had an accident, they have heavy menses, but the point is they are losing blood, whole blood. Okay? It means the total volume will decrease. That is sensed by baroreceptors. Where are they found? They are found on the arc of the aorta, and the carotid body. So the common carotid does not bifurcate like that. There is something called as the carotid body. That is why you get to find the baroreceptors as well as your chemoreceptors. But the chemoreceptors are more important in respiratory system because that is where carbon dioxide and hydrogen come. They are mostly involved in detecting hydrogen and carbon dioxide. But the baroreceptors, they sense the pressure within the arc of the aorta. If the amount of blood that is being pumped into the arc of the aorta is not as much, then they will sense and then they will send information to the brainstem via two cranial nerves, which are you guys following? So this person has been bleeding. I just want to appreciate how tachycardia comes in. Okay? This person has been bleeding for whatever reason. They are losing whole blood. Their volume has decreased. Okay? So that will be sensed by the baroreceptors that are located in the arc of the aorta or the carotid bodies. That is why you get to find the baroreceptors. So that's an overall. So now, because remember, blood has been, if the person is losing blood, even the blood that is going to the heart is not as much. So even the blood that will be pumped out by the heart won't be as much. And those baroreceptors, they are mechanical receptors. They will be able to sense that the amount of blood coming in this arc of the aorta is not as much. So they will now send impulses to the brainstem. Now I'm asking, what are the cranial nerves involved in that difference where they send information to the brainstem? I said you should always be guessing Vegas at least. Remember Vegas. At least you mention the Vegas. The Vegas will always be correct. As long as it's anything that is above. So the Vegas and the glossopharynx. These are the two nerves that will get information from the baroreceptor, take it to the brainstem, and I did talk about the cardiac center. Okay? The cardiac center is made up of the accelerator and the decelerator. Now this person is losing blood, and it means the heart has to start pumping at the accelerator. Which of the two will be stimulated, will be activated? The accelerator, and then the decelerator will be suppressed. So the nerves that are coming from the accelerator will go to the SA node, stimulate it, and then to start pumping fast. And then that will result in your tachycardia. Is it making sense?
Yes.
So I singled out one which is bleeding, and I gave an explanation. That's how your final exam question will come under scenarios. They will give you a patient who has an infection, then they will tell you to explain the compensatory mechanism. Okay, that's how the question comes. So if I don't know if you've been studying, I hope you've been studying what I'm teaching. Okay. First, we're almost done. Sinus bradycardia, these are the possible causes. So, bradycardia, decreased heart rate. What are the possible causes? Increased parasympathetic activity or decreased parasympathetic activity. It means when you go to your brainstem, the one that is activated is the decelerator. Okay. All right, so that's now a summary of the possible causes of tachycardia and the possible causes of. There is no such a thing as pharmaceutical. You need to know. Those are your things that I won't be asked to talk about the possible causes of tachycardia. I will ask you how do I manage heart failure? Okay. All right. The PRQRS QT about 5 minutes and then I'll be done. 5 minutes because you now understood the when you are at rest, rest and digest, right? That is the and most times, all your life life of life, so when you are right, someone is sick, you do your ECG, so you find it by the time it shouldn't alert you. Because the person, someone is fully awake, but they are in particular, within the cycle, they try to get forward. That's what so at the Tuesday, so let's quickly talk about QRS and QT. It will be fast in 5 minutes. Then we'll go through at least 3 questions and we'll go into it. Okay, and then Basa, like we can now go to at least I've opened like some doors for you. You can now supplement. I've just mentioned you need to go and read. Because for example, on the
Yay! Physiology is on the 24th. Physiology will be on the 24th of October. Physiology exam will be on the 24th of October.
So our homework, how do you calculate the heart rate when there is irregularity in the interval? He can bring an ECG this question. So go and find out how do you calculate the heart rate in the case where you have an irregular heart. Okay. So after calculating your heart rate, the next step is to measure the PR, QRS, and the QT. So you're given an ECG, you read the patient's details, you check those material boxes showing that it's adequate, and then you measured your heart rate. Don't know whether you found it to be tachycardia, or normal reading. You have to comment. The next step now is you have to measure your PR interval, your QRS, and your QT interval. This is the last thing you will do with me, and then the rest you will go and do on your own. Okay? There's all those. And I know you're studying nothing. Oh. So unlike heart rates, PRQ is a you might be forgiven if you miss out heart rate. But if you miss these, then you won't be forgiven. They can think that this person will end up being a victim in terms of. So these ones are a must. While you can be forgiven with the heart rate, these ones are a must. And take note that the PR, QRS, and QT intervals are measured using limb leads. Those leads that are connected using our extremities, and not those that are connected on our free body. Okay? So you can measure any of these using any of those that have been listed, except V1, V6. Okay. So you can see this ECG. It only has limb leads. Okay, V1 limb lead 1, 2, 3, LVR, LVL, and LVL. And at least I mentioned that memorize that LVR always have the QRS going down. So that's normal. So this ECG is normal. That's like it. Everything else should be positive. Okay. Now this is showing the number of boxes in seconds as you are moving. So now how you can get a PRI interval? Okay. So the PRI interval measures the duration of time from the very beginning of atrial activation to the very beginning of the ventricular decolonization. Okay? If I go back to this data, we are just saying from SA naught all the way to SA naught all the way to where LV naught is. That is what PRI interval measures. Okay? So quickly, see how do you measure PRI interval? It's from P at the end of, at the beginning of P wave, where the P wave is starting, and at the beginning of your QRS. So you count the number of boxes in between, and then multiply it times 0.0404. Because each of the smaller boxes is equal to 0.04. True or false?
True.
So like in our example, though it's hidden there. That first arrow is showing that is where your P is starting from. That other arrow is showing you that is where your QRS is starting from. So there are about 3 boxes. So 3 times 0.04 will end up finding the PR interval, as simple as that. Okay? So you should now be able to know the norm. So about knowing the norm, anything that is above or below becomes it. That's why I think you need to know to say that if there is a delay in the conduction, because that PR interval tells you how fast the conduction is between the atrium all the way to the ventricle. So if there is a delay, then there is an atrioventricular block. Okay? When the PR interval has been prolonged, the normal should be 0.2. If it is greater than 0.2, it just tells you to say that the movement of impulses from LV node all the way to SA node all the way to the LV node has been delayed. There is something wrong in that pathway, and that is why there is a delay. And we are saying if there is a delay, then you have what is known as atrioventricular block. Okay? There are 2 types. There is the first degree and the second degree. Just check your MCQs under CPS. Those are the things you will find. Check your MCQs like, oh, when you're driving, like just sit down and just go through it. You will realize these are the only things that MCQs are comprising. So it means take right down. I know I'm not studying today, I understand, because you are not studying for something. when the test is happening. So concentrate on your anatomy, pass your anatomy, but write somewhere to say, I need to study this. Okay? And these are the possible causes of AV growth. Okay, it can be drug intoxication, coronary artery disease, and the like. Okay, I'm moving on to the other parts. Okay, that's enough. Go home. Remember, I said if it is prolonged, you end up having atrioventricular block, okay, which can be first degree or second degree. Okay. If the duration has been shortened, there should be a disease as well. Okay? This disease is talking about when the value is greater than 0.2. We are saying you have atrioventricular 0.2. If the contraction is so fast that it is less than the norm, then now this is the disease that I put for you as a homework. So go and read it up. So just be taking note of it. I cannot teach everything. That's okay. So I'm just pinpointing things. For me, it's about the exam. Like if you pass exam, okay, so you just focusing on the thing with you. I'm most likely to find the MCQ for your exam. Okay? All right, we move on to the QRS interval quickly and how to measure it again. But if you are tired, you can go. No, like serious. I understand. I actually looked at it myself. Okay? So after PRI interval, the next step is now measuring your QRS interval. So the QRS interval is what you are now interested in. So QRS interval represents the amount of time it takes for the electrical impulse to depolarize the ventricle. So how long does it take for the ventricles to depolarize? That's what QRS interval stands for. So the normal, so here, just memorize this to my values, guys. The PR is 0.2, memorize it like that. The normal QRS interval is 0.09, you have to memorize. Those are the questions that will be done with you. Okay? So how to measure QRS interval? Again, it's very simple. That QRS, just count the number of boxes you can then multiply by 0.04. Okay? Look at this diagram there, at least it's not here. So you can see from the beginning of Q and at the end, there are about 2 boxes. So 2 times 0.04 and found 0.08 seconds. So that is the QRS interval. But is it the normal? Yes, they said it should be 0.9 or less. So this is a normal. Okay? But you can have abnormals. So what happens? What is the critical relevance when it prolongs? So you end up having intraventricular conduction delay. Okay? Which is also known as IVCD. It's abbreviated as IVCD. Yeah. Bundle branch block. Those are the possible diseases in a case where there is a delay, there is an issue in short with the QRS. So again, write it down so that when you do your anatomy, you can now go through these things in your canon. The last one, QT interval. Okay, so QT interval, this is the last interval to be measured on the ECG. And by the time, when you are done measuring this, that is when now you can conclude your diseases. Okay? So the QT represents the time it takes for the ventricles to depolarize and then resets or repolarize for the next cycle. That is where the contraction happens around, right? Okay? So from the beginning of Q to all the way where the T is ending, that is the QT interval. So again, it's very easy to calculate. The number of smaller boxes which represents 0.04 seconds. So the number of those boxes times 0.04, you end up finding your QT. As simple as that. So you have to know the diseases as well. Okay? These are not teaching, but it now goes back to the beginning. Common clinical arrhythmias. So arrhythmias, Okay? I'm not teaching, but I'm writing my point so that you understand. The only arrhythmias you should know as a third year and the second year is atrial fibrillation is a must. Even myself, the only one I read is atrial fibrillation. Ventricular fibrillation, okay, and atrial, okay, those are the only ones you should know. Atrial fibrillation is okay. I've talked about this. I'm going straight to the question. I've talked about this. Okay. Mr. Z, a 70-year-old is admitted. I just forgotten it from the exam. Mr. Z, a 70-year-old is admitted to a hospital with history of dyspnea on very mild exertion and octopia. He has a cough with frothy sputum. He has a raised jugular venous pressure and clearly demonstrates the various waves of the jugular venous pulse. However, the heart rate is irregular and irregular. They are telling you that this is an arrhythmia. Okay? He has a recent record from the echocardiogram which shows that he has an ejection fraction of 26%. So I'll skip these other questions. We can see octopia is under respiratory infection. So this question was a combination of CVS and respiratory infection. So the first question was under respiratory. The second question is CVS, jugular venous. You have to know those waves. Then C, what is the ejection fraction? No, where is the one for? Oh, it has been hidden. Let me go and read it down. The D is the question of interest. So, describe how you would calculate the heart rate using electrocardiogram recording. And now take notes. Whoever asked that question is you are the one, right? Yes. They are saying this is an irregular and irregular. If you are going to use the 1,500, you are gone. So, Siemens are on the internet. Emphasis, I was saying to say, go and find out how to measure the heart rate when it is irregularly
Regular.
All right. I'm just going to do MCQ. Oh, this question is actually have idea, then you are done. Given an RR interval of 20 millimeters at a standard ECG paper speed, what is the heart rate? 5 marks. Imagine someone failing that question. We've told you this is a standard, we've given you the number of boxes. Okay, that 20 millimeters is the number of boxes. So just dividing 1,500 by that number or 1 2, and we are going to give you 5 marks. So just be careful when you are writing your answer. Don't just write 500 divided by 4. You have to make sure you include the units, you cancel them, and then achieve this to have this. Like you have to show your weight. Even though it says the formula is this divided by this, where this value stands for the number of boxes, which is 20 millimeters according to this question. You substitute, you cancel whatever is supposed to be cancelled, and you're going to get to 5 boxes. But someone who's just going to punch 1.5 divided by 20, you are going to get the 1. Okay? As simple as that. The other one, discuss the expected ECG changes noted following carotid sinus stimulation. If you heard what I was talking about, carotid sinus stimulation, the carotid, that's why your baroreceptors are. Now if you stimulate it, you have to talk about financial companies. What is the brain stem? You have the cardiac Okay. All right, we are done. The arrhythmias I've told you the at least mentioned what you need. Okay, but there's all those to know. So I think from here they now